to the presence of the metastable A15 structures, which I'll get into in the talk of this in my presentation. Now, these A15 struct phases are found within the bulk samples of the molybdenum system in their phase diagrams. Now, the aim of this study, therefore, since this system of the molybdenum system has been studied by many scientists, is to find now what is the impact when one dopes this system with chromium. So that's the aim of this structure. So we only drop, for the purpose of this talk, we only use 5% chromium doping within this structure to find the effects, therefore, on the structure. Now, there are so many applications that one can find for these molybdenum systems, which, to begin with, one can talk about how they are settled in water. When talking about environmental sciences, they tend to have applications in space nuclear power as well. For example, when one talks about how they are used for fuel cladding in ADSWE cooled reactors, they also have an application in aerospace as well. When one looks at the Prometheus reactor in Idaho, which has to do with gas-cooled reactor, right? Which they were also planning or actually are using these systems in their reactors. They also have applications when one looks at just molybdenum alone. It is applications in medicine. It is applications in metallurgy and electronics. The same can be said for rhenium as well. It has got many applications, which then imply that when one then combines this system, one should expect that one can get many applications from this such system. Now, based on the low solubility oxygen, we want these samples have been considered for microwave cavities, which is another application that they have, and they've been used as base electrodes in counter-electrodes tunnel junctions. So there are many applications that one can use with these alloys that we're dealing with, and I put the literature as well. Now, how did I get to synthesize these materials? We used the arc melting technique, where we used high purity alloys of approximately 99.99% percentage in terms of the purity, and we talked about the molybdenum, rhenium, and of course we used chromium. Now, in terms of the synthesis, the elements were melted together. In fact, they were powdered first, then they were pressed by using a drill press, melted together in an arc furnace. And in that situation, they formed what are called buttons, or rather some button structures. And these button structures in the melting were flipped about 3 times, and then they were crushed and then remelted again in order to ensure that one can get a complete homogeneity. So that was done for this one. And in each melting phase, there was at least 3 flips every single time. Now, the structure and composition was confirmed using energy dispersive X-ray spectroscopy.